quite a small crowd here, and I basically decided to give this talk at the very last minute. The original plan was just to do some live coding. However, I started doing some slides. In the end, I ended up preparing some slides. I didn't prepare any live coding at all. So I might try and do a little bit of live coding, but we'll see how it goes. But please feel free to interrupt me at any time and ask questions. All right, some finite state machines. According to Wikipedia, I'm not going to open that. You can open it if you want to. So a finite state machine is a mathematical model of computation. And probably one thing of particular interest about a finite state machine is that it's less powerful than some other models of computation, in particular the Turing machine. So why would one want to use something which is not as powerful as something else? And I guess the main idea is that it restricts you from doing certain things, and it restricts you in a good way. It forces you to use a certain formalism and keeps you from making big mistakes. So thinking convention over configuration. Okay, so the formal definition, I'm going to skip that. In particular because I don't know how to render LaTeX inside of org mode yet. So we'll just go to an example. So I'm using a tool called PlantUML, which lets you describe state machines, amongst other things. It also lets you do some activity diagrams and just general other UML stuff, which is really cool. And oh, wonderful. Doesn't zoom the image. Okay, can you see the image at the bottom?
Yeah.
Okay, so this is a simple state machine. It has two states called locked and unlocked. Its initial state is locked over here. So this little dot is an indicator which shows that this state is the initial state. And this, all the arrows are called transitions. So this particular arrow is kind of like the initializing transition. It's implied. And the state machine accepts two types of actions, or in the mathematical formalism, you call it alphabet, or the input alphabet. But let's call them actions. So this accepts the push action and the coin action. Coin action corresponds to you putting a coin into the turnstile, and the push action corresponds to you trying to push the turnstile. So if it's locked, you put in the coin, it becomes unlocked. You can keep on putting coins. That doesn't change the state. But as soon as you push, the turnstile becomes locked again. And what you can notice is that you can't push while you're in the locked state, or at least this machine does not allow you to push while in the locked state. And this is on purpose. So it basically prevents you from doing something bad. Let's have a look at another example. A little bit longer. So 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7 states. So probably the most interesting part is the names of the transitions. So here, so we have an initial state A, we have a final state F. So that's the, so this indicator is, means this is the final state. You can't transition from here. Like once the state machine reached that state, that's it, the program is terminated. So you might want that or might not want that. The previous one didn't have a state like that. So the state machine lives on forever. So what does the state machine do? It accepts an action called E. Then, okay, this is really bad. So this is an arrow which loops upon itself, also labeled with E. Then it accepts, then there's a transition called M, a transition called B, then a transition called E, then another one which loops upon itself called E, and a final one called R. and I'll show you what it does in a minute. So it's over here, which brings me to applications of state machines and software. So one of them is regular expressions, or to be more specific, it's regular languages, which is a subset of regular expressions. But I'm not going to go into too much detail about the differences. So if you look at this as a regular expression, it either takes letter E one or more times, or a letter A one or more times, then the letters M and B, and then the letter E one or more times, and then finally letter R. So this regular expression corresponds exactly to the to this state machine right here. So you can use state machines to model your application behavior. So that's what you would call state design. But they're also pretty good to modeling event-driven behavior, which pretty much all front-end applications are. I mean, they're wait user inputs and react to user input. So look what else is there? I can try and do some live coding, just as a little illustration. So this number twiddle. Okay, let's just create a component. So I'm going to make a component which lets you log in and log out. Just displaying a button. Sorry, can you remind me what is it value? Does this work? No.
Oh, you need to add it to your else.
Thank you. Okay, here we go. Can you see that?
Well, maybe it is.
Okay, it's going to make it harder to edit the code, but whatever. Okay, so this button does nothing. For now, let's say we add an actions hash. We do a login action. So usually when you log in, okay, so okay, let's start out with this. Okay, it doesn't do anything because we haven't connected the action. Button on click. Okay, here we go. Okay, so now we went from login to logout. Do the same thing to logout. log in, log out. Okay, now this is a little bit unrealistic because usually if you log in, you need to send an HTTP request to the server, you need to wait for it to authenticate, so it's going to be an asynchronous action. So we could say, so how could we emulate this? Ember run later. Let's say we run it a second later. So we click login, and this didn't work because we need this. There we go. So what's the problem with this? You can click login several times. So we might want to disable the button right when we click it. So this set disabled true. Say the component. How do you do this attribute binding? Is this going to work? Nope. There we go. Something happened.
You got it disabled to the logout.
Okay. So we probably want the. Oh, thank you.
It's always going to be disabled. Yeah, HTML5. Never undisabled. You just do disable equals and then it's from. What they're going to Ember and then interpolate.
Sorry?
Interpolate the property.
There we go. So that worked. We'll log back out. Oh, look. The button's still disabled. All right, so I guess like that's the smallest example I could think of right now to illustrate the benefit of a state-based design. So what's happening here? If we look at the code over here, so we have an online Boolean variable and we have a disabled Boolean variable. So each one of those can take one of two states. So the total state space of our component is actually 2 to the power of 2, which is 4. However, what we really want is only to have 3 states. So we want the state where we see the login button. We want the state where the login button is disabled because we're currently logging in. And we want the state where we logged in and we have a logout button. And when we click that, we want to end up in the state where we just have the login button, which is enabled. Right? So of course, what we can do is we can also set this so this works. But let's say, all right, I'm not going to try and come up with more complex examples. The thing is, like, once you start adding more and more Boolean variables, you can end up with a state space which is potentially huge, whereas what you really want is only a very small subset of those states. And what can happen is if you change the code, at some point somebody doesn't pay attention to what one of the Boolean variables does, and you might have an inconsistent UI, basically. All right, let's go back. So there are a couple. Oh, actually, this is exactly the example that we had. So there were a couple simplifications to state machines. So basically, this is a state machine which has 3 states: disconnected, connecting, and online. However, we can group 2 of these states together under a superstate called offline. Now this can have several advantages. One of them is, for instance, if you want to render something in the UI, if and only if you're in the offline state, you can just check, is your state currently offline, rather than checking explicitly, are we disconnected or connecting. So it saves you one end in the template. What else? So over here, we have a transition called disconnect. Once that transition is initiated, me as the programmer shouldn't really worry about, do I want to go into the disconnected state or do I want to go into the connecting state? And that's because we have a default state. So inside the offline state, the default state is disconnected. So once I transition back to the offline state, then by default, I end up in the disconnected state. So it's just basically a way to save yourself some action. So I guess like the other one which we don't have here is if we had an action going from the offline state. And this basically means that we want both the disconnected state and the connecting state to behave in exactly the same manner when that particular action is called. Then we would draw the action from the offline state. And I'll draw the parallel to Ember in 2 slides. Okay, so, oh no. Oh, here we go. So the other simplifying concept in state machines is concurrent state. And I guess concurrent state pretty closely corresponds to what you, or at least this particular one, pretty closely corresponds to what you get if you use Boolean variables. So if you have 3 Boolean variables, then let's call them numlock, caps lock, and scroll lock. And this pretty much describes this particular state machine. And so this is supposed to model a keyboard, which has 3 modifier keys. So you press numlock, and then depending if numlock is on or off, you go into the other stateful numlock. Similarly for caps lock and scroll lock. But they are independent of each other. So basically this state machine has 8 states overall, 2 to the 3. So I find this is sometimes a helpful way to model this if you're drawing out state machines, but in terms of programming, it doesn't really make things easier. So I think it's easier if you do want to have concurrent state, then you just basically define 2 independent state machines. And then your overall state is basically the product of these 2 states mathematically. Or you just use Boolean variables. Oh. Okay, so Ember and states. So I have a copy of Ember.js on my drive. And I just run a grep for current state. And these are my results. Ember Glimmer, Ember Routing, and Ember Views. And I'll get to that in a second. I also ran it on Ember Data. And there's a couple more add-ons, a couple more results. But I guess the most important one is this one, model. And internal model, so it's both of them. So Ember does use some state machines internally. What are they? Okay, so I'm not going to through all of them. I'm just going to concentrate on Ember routing mostly. Well, I'll talk briefly about Ember routing. I'll talk briefly about Ember data. Ember routing, which hopefully you're all familiar with. So in Ember routing, you define the state machine yourself. Or rather, you define the states of the state machine and you define the transition rules. And then Ember takes care of setting your current state. And your current state is the route which you are in. We do have some hierarchical states, which are basically nested routes. State-dependent behavior is invoked by using this.send, sending an action on a route. And you can transition between states explicitly by using the transition to function. And Ember routing has a couple nice goodies, including bubbling of actions and the activate and deactivate hook. So, which basically lets you do some cleanup work or some setup work independent of how you enter or leave a route. So Ember data also has a state machine. However, that state machine is defined by Ember data itself. It's a hierarchical state machine with a couple almost concurrent definitions. It used to use a library called Ember States. This library is now not supported by Ember officially anymore. So basically the code was half copy and pasted and modified inside Ember data. So I dug around a little bit and I managed to come up with the following diagram. So this is the source code for the diagram. And as you can see, a lot of the transitions are commented out because basically they would completely blow up the diagram. Here we go, that's the picture. And people who have dealt with Ember data are probably familiar with some things like the root state, root.loaded, root.loaded.created, root.loaded.created.uncommitted, or in flight, and so forth. Updated. There's also root.empty and root.loading. Actually, there's quite a few state transition missing from here, so I tried to make a slightly simpler diagram. So basically in Ember data, you start out, when you create a new Ember data model, this model starts out its life cycle inside the empty state, or really it's root.empty, but I'm not going to write root everywhere. So it's empty. Then once you're loading data, it's loading. If it's loaded, then it's in the loaded.saved state. If you created the model yourself locally, then it will be in the uncommitted state. So all of these are basically newly created models. These are models that are loaded from the server. And these are models that are about to be deleted. So like once you delete a model, it's not deleted immediately. You still need to call .save on the model. And then basically they transition inside these states over here. And if you look at the substates, they're actually quite similar. So there's in flight, saved, and uncommitted. And it's the same for the loaded state. For the created in flight, uncommitted, in flight, and uncommitted. So if you look at the actual implementation, like some things are sort of similar, but some things are slightly different. So what the Ember data guys did is they used object orientation and inheritance of objects to emulate similarities between the different states. So it's not really truly a concurrent state machine. Anyway, so this brings me to what else can you use state machines for? We had state machines for models, we had state machines for routes. There's also some internal state machines for components. There's a certain component lifecycle. I haven't looked at exactly how that works, so I'm not going to talk about that. But two natural things which I guess you could see from my example over here. We're modeling a component. So anything that has semi-persistent data. So not data that you might want to persist to the server, but data which is long-lived during a session and might change state. And like an Ember is one of two things. Either it's a component or a service. So these are the two most common use cases. So this is the Ember States library. I'm actually gonna, this is not the GitHub library as you see, but this is some old documentation code for Ember version 1 release candidate 3, after which this library was removed from Ember proper. but it shows how to use this thing. So you create a state manager. Inside the state manager, you create a couple of states. So this is hierarchical, as you can see. And then you use transition to transition to other states. And I think this is a full example. So you define your initial state, power it down. It also has some enter and exit hooks. And I'm not sure how you explicitly call the, oh, here we go. I'm just going to create. Yeah, and use send to send an action. So this is very similar to the routing thing. And I'm not sure if Ember Stateful was ever intended to be used in the router or whether it was used in the router, but certainly the terminology is similar. However, it's not really maintained anymore, and I didn't really like the fact that you have to create a state manager and then a state. I like just basically creating lots of extra objects. So the next example is IV stateful. 1 star, 5 watches, 0 forks, 9 commits, 3 years old. Doesn't have to mean it's bad though. This is actually a lot simpler. So it uses it basically exposes one mixin, and it lets you define your state machine on this object, root state. So the roots, so you have the park state over here, the idling state over here, and first gear state over here. Each state can have its own properties, and each state has actions. You also have an enter and an exit action, presumably to working as the enter and exit hook. And you move between states by calling transition to. So relatively similar. What is vehicle? Oh yeah, and every state receives apparently the state machine as the first parameter. And this is how you set states, presumably. But as you notice, this doesn't let you have hierarchical states. And yeah, I don't like the fact that you get this vehicle thing over here inside the action. You have to use this root state thing over there. And you sort of, yeah. Well, it does have an initial state, so that's good. Anyway, there's one more. Actually, there's 2 more, so we'll get to that. So this one is a lot more popular. Also hasn't been updated in 8 months. A lot more commits. I haven't examined it in too much detail, but from what I can tell, it's basically seems to be just as complex as this one, as Ember States. Plus, it claims that it is promise aware, and I'm not entirely sure what that means. So, but I guess one of the biggest downsides is, well, 2 downsides. It's rather complex, and it's also not hierarchical. So you define your states over here. Then every state has a lot of different hooks. Will enter, will exit, did exit. And here you define events. So events are like actions. And there's some extra stuff that you can define in actions. And then basically this tells you that if you receive an action event and you are inside this state, inside a wake state, then you transition to the sleeping state, or something like that. Basically, I didn't understand immediately how it works, and plus you get these macros, expand all known states, same initial. So I don't like this. So what do you do if you don't like something? Okay. I'll show you this in a minute, but I'll tell you my motivations behind this. So I wanted to have something intuitive. So I like the I like the original Ember States to the extent that it uses some terminology we're familiar with. It uses transition to, and it uses send. So send sends an action, transition to transitions to a state. So I wanted to keep that. Moreover, I wanted to keep the actions hash because we already use that for actions. And I wanted it to be hierarchical. So I wanted to use the actions hash, and I wanted to have bubbling just as you do in routes. So if you return true from an action, it's going to bubble up to the next state above. And one conscious design decision was that transition to is a synchronous function. So basically, if you're doing concurrency, if you're doing some asynchronous stuff, you have to take care of it yourself. So, and we'll come back to this with the example in a second. Okay, so it's mostly 3 months old. I expect this to go up after tonight. Usage is just a simple mix-in. So like the entire add-on is just one file, about 140 lines. All it does is override the send method. Wait, is that true? Okay, so okay, it does something in the init thing, and yeah, and it overrides. Sorry, it overrides send, and yeah, and it adds transition to. So let's have a look at how to use it. You define your states explicitly inside the states property. If you want hierarchical states, you use dot notation. So on.idle is a substate of on. On.active is also a substate of on. No complicated nesting of hashes or whatever. And you define your actions as you would inside your actions hash. However, if you want some actions to only happen in specific states, then you create a property inside the actions hash with the name of the state, and you define the action inside that state. So for instance, if you're inside the on state, and if you call turn on, then it will execute this. We're turning on, but then it will actually bubble, so it will also execute this bit. If you're inside, what am I missing? Off. Okay. So if you're inside off, we don't have off inside the actions hash because there's no specific actions we want off to take. So if we don't want any specific actions to happen, we just put them just at the top. So if you're inside the off state, then and you send turn on, then the default action will be executed. So what's the advantage of this? Basically, you can add this mix-in without modifying your existing code. So unless you have the states variable used for something else, you can just add it and then gradually improve your components or services. The other thing that it does, we expose a property called state. And that property is quite clever. So if you're inside the off state, then this will be truthish. So this will actually evaluate to a hash, to an empty hash, which in JavaScript land is truthish. So you can use this in templates quite easily. So rather than, so for instance, over here, if we had the Boolean variables for idle and active, so over here we would have to do if or idle active, but instead we can just do if state.on. Some description about asynchronicity. Anyway, let's go back to our example right at the beginning. I think it's this one. All right. And let's see how we can gradually make this into a stateful component. So first thing we do is we copy and paste some code from here. Okay. My components, we import stateful from Ember Stateful, and is there an error?
You have to define state.
Thank you. Huh, and it's working. Okay. So what are the states that we want? We want the state where the button is, where the button is says login and is active, where it says login and is not active, and when it says logout. So logout, so this state could be offline, and the next state could be connecting, next state could be online. Move this. We immediately start connecting. Okay, now what I'm doing here is not very nice, and I'll show how to do it properly in a second. Just trying to replicate the okay. Sorry? Thank you. Okay, log in. Nope. Something wrong. No, it's not. Oh. Okay. Joseph thought. Yes, thank you. So we didn't have a state for the connecting thing. So basically here we'll need if state is offline or state is connecting. And we'll mitigate this problem in a second. And we want it to disable if we are connecting. What's wrong this time? Or is not a helper. Okay, what's the Ember truth helpers? Somebody look up the recent version. That works. Is that gonna work? Montreal. Wait. Oh yeah. That's the that's something I prepared earlier. This is our example, right? Okay, here we go. So, A works like a charm. However, this is quite ugly. So we have an OR helper over here. So maybe these two states should be grouped together under a superstate. Where do we have the component? Okay, so let's call that superstate. Actually, let's call it offline and have two substates called connecting and disconnected. Okay. Okay, so this didn't work because this is wrong.
The transitions need to be changed.
Thank you. Okay, so if we're in here, transitioning to offline connecting. Okay, also, what I didn't mention is some of the other implementations. If you're inside the a substate, then sometimes you don't have to specify the full substate you want to transition to if it shares an ancestor. So it lets you take some shortcuts. Like if we were in the disconnected state, we could say transition to connecting rather than transition to offline connecting. However, I think this is a bad thing. It's error prone. And I insist that you always specify the state explicitly. Okay, so this is all fine. As you notice here, this transitions to the offline state. So what does that mean? So we click on logout, we're in the offline state. So there's one more property exposed by the stateful add-on, and that's called Concurrent State, just as it's called in some of the other some of the Ember source code. Be careful, don't mix it up with underscore current state, because that's something actually used by the Ember framework on components. Here we go. Offline disconnected, offline connecting, online logout, offline disconnected. So why is it disconnected? Because it's the first one, exactly. So I didn't want to have an extra property called initial state. It's just the first one. So what happens if we put it as the next one? Okay, so we start out in the connecting state, and we basically screwed because we can't have this, can't click this. Okay, let's try it differently. What about the online state first? Okay, now this is not ideal as well. Okay, what happened here?
Offline connecting is the default offline state.
Yes, exactly, and that's because it's the first one as well. So during the setup, we go through the entire state hierarchy, and we, for every superstate, we always have a default substate, and this corresponds to the order of the states. So I thought that's sort of a nice, simple way to, a very concise way to basically restrict yourself from doing some things and having to do them manually. There's probably two more things I could show. One of them is, okay, let's have this one as the first one. Damn it. We keep another 5 minutes?
Oh, that's fine. No, just cut out. I just want to make sure it was okay. It's good.
Okay. So, all right, so it also works, like, they don't have to be in any particular order either. It's clever enough to figure out that this and this have a common superstate. What we can do is, okay, let's make another button. Actually, two more things I can show us. Sorry.
Got the typo in action.
Thank you. It's this new keyboard. Can't get used to it. Okay. Let's say we want to prevent people from trying to log out while they're already logged out. So we could put this logout action inside the online hash. So this corresponds to this action. And basically this says, if we're inside the online action, then execute this when we send logout. Okay, so what happens if we log out? Everything is fine. So if we do this, everything is fine. Okay, what happens if we click this? Error. Okay, let's try it again. Error. Can you make this? How do you increase the size of this? Sorry? Command plus. Ah, excellent. Okay. Root action named logout was not found in the component. And that's because the only root action we have is login. So we can have another logout action. If we're actually logged in, then it's fine, that it does what's expected. If we do this inside here, then it will execute both actions, right? So that's bubbling for you right there. Okay, one final thing if we have another 2 minutes, is that right? Because basically, what we're doing here is we're defining two transitions inside a single action. So we're saying transition to offline connecting, and then later at some point we transition to online. So this is conceptually not great. So what we could do instead is inside the offline connecting, inside the offline connecting state, we have the enter action. I could put this code in here. So this indicates that the connecting state does pretty much nothing else but just wait for a promise to resolve. And then at the end, once it resolves, it transitions to a different state. What are the advantages of doing something like this? Okay, let's give it a slightly, that's too long, slightly longer timeout. Make sure it still works. Yeah, it still works. Okay, let's say instead of doing a dump logout, we do a stop action. That basically stops whatever you're doing. Yeah. Okay, well, it does pretty much the same thing as logout for now. I guess the only difference is there we go. Okay. Whoa, what happened there? So, I mean, we're already disconnected, so that's fine. If we're online, stop will disconnect. Actually, you know what? Oh, let's call it, yeah, let's keep it called stop. So what happened here? We click log in, then we click stop. Okay, and then something happens. Basically, while we're inside the connecting state, we're clicking stop. We're transitioning synchronously to the disconnected state. However, later this promise resolves, and we have another transition into the online state. So probably what we meant is that we want to cancel the connection. So inside stop, we could call Ember run.cancel this get t. Stop. This works as expected. However, okay, what happens if we call stop over here again? Actually, nothing happens. I was hoping there was going to be an error because you're trying to cancel a timeout which has already been canceled or whatnot, or it doesn't exist anymore. But as you can imagine, like if you're trying to cancel a promise or try to cancel an Ember concurrency task, for instance, and that task is not running, again, so like something unexpected might happen. So this is exactly what the exit action is good for. And this basically says like once you're transitioning out of this specific route, we can do some cleanup work. So in this case, there we go. Again, stop. Again, online, stop. Works as expected. And what's the other advantage of that? Now stop has exactly the same implementation as logout. Well, actually, let's go back to how it was before. Yeah, so before stop had the cancel and then transition to. Now it's exactly like the logout route. So in fact, over here, we can just call the action logout. And we can remove this. So I guess like another way you could have done it is you do cancel timeout, and then you do this.send logout. However, here you're chaining more than one action onto each other, and again, it's an easy way to get lost. So I think it's much cleaner if you handle this with enter and exit actions, and like basically, it's a nice way to display asynchronous state in your UI.
Thank you very much.
Thank you.